Hi, everyone. My name is Nithila Sadheesh, and today I will be presenting my project on the comparison of machine learning models for COPD detection. So first, I will briefly introduce myself. I will go over the background of this project, the application of AI in broad terms. I will do a brief literature review by discussing previous work. I will go over my project-specific details, as well as finally the models and results of the project. Okay, so first I will start with an introduction. Once again, my name is Nithila Sadheesh. I am in Dublin, California right now, and I worked with my mentor, Joe, to complete this project over the last few months. And my inspiration behind this project was seeing AI being utilized in many different domains around me with natural language processing like ChatGPT and image recognition through self-driving cars. I was inspired by how popular it was becoming, and I was inspired to learn about it. After I learned about it, I was inspired to actually implement it myself. And I was specifically interested in healthcare because of its ability to directly impact people, as well as the relatively limited exposure healthcare has had to AI compared to the other fields I mentioned. Okay, so the background of my project. The aim of my project was to classify COPD. What is COPD? COPD is chronic obstructive pulmonary disease, and it is a prevalent progressive lung disease that is characterized by airflow blockage and breathing-related difficulties. It is quite a severe problem in the healthcare space. In fact, the World Health Organization predicts COPD to be the third leading cause of mortality worldwide by 2030. And not only is it prevalent, but it has many severe effects. Its effects include heart problems, pulmonary hypertension, lung cancer, and depression and anxiety. And furthermore, it places a significant burden on individuals, families, and the healthcare system. Okay. AI has, and more specifically, machine learning has risen as a promising tool in medical-related tasks and diagnoses. It is able to be so effective because it identifies patterns that go unnoticed by the human eye by using various computational techniques. And while there are studies that have laid the groundwork for ML-based COPD detections, there are gaps that remain in understanding its comparative performance with other ML models, which is the problem I hope to solve with my project. So first, before I get into what I have done with my project, I'll explain what is currently being used to diagnose COPD and how ML has been applied so far. So current diagnosis of COPD utilizes a combination of clinical assessment, pulmonary function tests, and imaging analysis. Spirometry is the most widely used pulmonary function test, and it measures the volume and flow rate of air expelled from the lungs during expiration. And while spirometry is the standard for diagnosing COPD, it's limited in the sense that it requires specialized equipment, it requires trained medical professionals, and it is often unable to capture subtleties during the early stages of the disease. And there are other tests as well, such as chest x-rays and screening blood tests. However, they more so measure the overall state of the lungs rather than specific information for COPD diagnoses. So machine learning has been applied to various different types of data to diagnose COPD. So this includes spirometry data. It has also been applied to imaging modalities like chest x-rays, CT scans, et cetera, and physiological signals like ECG signals. And a lot of these models have been able to and approaches have been able to achieve high accuracies. But the data I chose to focus on was audio respiratory data, as it is easier and cheaper for diagnosis, and it would allow for earlier intervention. Okay, so next I will go into the details of my project specifically. The data was acquired through the Respiratory Sound Database through Kaggle, and the database was compiled by 2 research teams in Portugal and Greece. The dataset included a total of 920 total audio recordings of respiratory cycles, each about 10 to 90 seconds in length, from 126 different patients spanning all ages. So the first step I took was visualizing the data. This helped me to see patterns and kind of distinguish between COPD and healthy patients, and prepared me for the next steps of the process. So the next step was to pre-process the data, and I won't get too much into the details, but it essentially involves transforming and organizing the raw data into a suitable form for analysis by machine learning models. And some of the steps I took as part of this pre-processing was feature scaling, which involves transforming the values in the dataset to a similar scale while still maintaining their relationships and distribution. And another thing I did is called SMOTE, which stands for Synthetic Minority Oversampling Technique. And this was to address the slight imbalance I had in my data set because I had more COPD samples compared to healthy samples. And there are several pros and cons to this technique, but I was able to identify if there were any negative effects on the data and on the diagnoses through various cross-validation techniques. Next was to extract specific features from the signal that would help the model know what to focus on and make more accurate predictions based off of them. There was a wide variety of possible features that could provide this information, and this includes things like statistical features, spectral features, and temporal features from the signal, each focusing on a different domain or different aspect of the signal that you can look at. I tested several different combinations of features and used different techniques to analyze which ones were the most helpful in diagnoses. And I was able to identify 7 key features by the end. And some of these included the MEL frequency scale, which is a type of scale that approximates humans' auditory response. And I saw it was really helpful in making the predictions when applied to the models. Okay, so next I will go over the models and their accuracies. So in order to evaluate the models, I used different performance metrics. I have listed the accuracies here as the accuracy metric is typically recognizable, but I also used precision, recall, and F1 score. So the first model I did was logistic regression, and logistic regression is on the surface level, a simple linear classification algorithm that models the probability of a binary outcome using a sigmoid function. And this model was able to achieve a 92% accuracy, which wasn't the highest or the lowest, so it was somewhere in between. The next one was a support vector classifier, which was a classification algorithm that finds the optimal hyperplane to separate data into different classes. And this was the least performing model with only an 88% accuracy, and this was reflected in the other performance metrics as well. Third was the random forest model, and the random forest model is an ensemble learning method that builds multiple decision trees and combines their outputs to improve accuracy and prevent overfitting. And this was able to achieve the highest performance with 99% accuracy and high performance metrics in the other ones as well. And then lastly, I implemented a neural network, and a neural network is one of the most complex machine learning models compared to the other ones I mentioned, and it is inspired by the human brain. So it consists of interconnected neurons or nodes to help make predictions. And the specific type of neural network that I used was the feed-forward neural network, and this achieved the second best performance with a 98% accuracy rate. So my project demonstrated that there's a huge potential for audio-based approaches in enhancing the early diagnosis and monitoring of COPD. And this was also just a great learning experience for me overall, as this was my first exposure to actually implementing and working with AI in the medical space. Thank you.
Awesome. Thank you so much. That was great. If anyone has any questions for Nithila, please feel free to put them in the Q&A. Otherwise, I'd love to hear what inspired you to do this project. I'm sure there's many ML topics that you could have chosen. Why did this one come up?
Yeah, I briefly mentioned this in the beginning, but I was first just very intrigued by AI overall, seeing how it was becoming so popular and it was being applied to so many different areas. But I was really interested in healthcare because I feel like it has one of the most impactful, it impacts people the most because it is able to impact their health directly. So I found it very interesting. And when I was doing my literature reviews and reading different articles, different papers, I found that there were many different areas where AI could be applied. And I found it really interesting how it was being done. So that's why I chose to study this topic.
Gotcha. And if you were to continue this research, what do you think you would do next?
Um, If I were to continue this research, I think I would try to understand more um, the reasoning behind why certain models performed better. I was able to do a high level analysis of this by comparing like different hyperparameters of the models and kind of matching that up, but I would like to go more deeply into it. But it is more of a difficult thing to kind of think about and reason out. But by reading more papers and just understanding more, that's something I would like to do.